Welcome to Chapter 9, Section 5, Quadrilaterals. A quadrilateral has 4 sides and 4 angles. So as long as it has 4 sides, it can be any shape you want. As long as it has 4 angles, it can be any shape you want. Quadrilateral is the most basic term. So if I showed you this shape, let me get a nice perfect shape in there. If I showed you this, most of you would want to call it a square because it looks like a square. The most basic term for it would be a quadrilateral. It has 1, 2, 3, 4 sides and 1, 2, 3, 4 angles. All right, and one of the key concepts here is that the measure of a interior angles of a quadrilateral is 360 degrees. You may want to recall that a triangle equals 180 degrees. So you could have a triangle that was 60, 60, and 60. Altogether, that's 180. Now, you get a quadrilateral by putting 2 triangles together. So there's another 60, another 60, and another 60. When you add all of those up, it's 180. And 180 plus 180 gives us 360 degrees for a quadrilateral. All right, so find the value of x in the quadrilateral shown. Since the sum of the angle measures in a quadrilateral is 360, you can write this equation. That's x plus 50 plus 130 plus 50 gives you 360. Once you have that, you then have to think about, you have to add 50, 130, and 50. I think that's 230. And then think, and use some mental math for right now, what measure added to 230 equals 360? So 130 plus 230 equals 360. Now we know the value. So here you go. This is another example of it. Altogether, this should equal 360 degrees. So start by writing the equation x plus 110 plus 70 plus 70 equals 360. All of the angles added together give us 360. So let's go ahead and combine these. Let's see, this is 140 plus 110 is 250. So x plus 250 equals 360. So now using mental math, what would I need to put here to make this equal to 360? I would need 110 plus 250 gives me 360. I now know that the value given, that x is equal to 110. Okay, here are some of the names. You have a rectangle. Well, this rectangle actually kind of looks like a square. The key, though, is some of this terminology, or some of these symbols. A square in an angle equals 90 degrees. Technically, no square, not 90. If there's no square there, then you cannot assume that it's 90, even if it looks like it is. Matching dashes. This dash matches this dash. So a matching dashes mean equal lengths. It means that they are equal lengths. So this side here equals that side. Dash, single dash, single dash, single dash. All of these are equal to one another. So when we're looking at this, we know this is 90, 90, 90, 90. All these things here with little squares in the angle means 90. This right here is not 90. All right? Rhombus, not 90, not 90, and so on. Notice here for a trapezoid that some trapezoids have this side right here and this side right here, they're parallel. All right, so this is something that is in your book, but not in your note-taking guides. It tells you a little bit about each of these. A parallelogram the opposite sides are equal and parallel. So right here, see how this opposite are equal because there's this dash, and they're parallel. Two dashes, two dashes. The angles are also equal. Notice here that there's two little arcs, two little arcs. It means that these are congruent, these are congruent, these are congruent, and those are congruent. Everything about the opposite sides, opposite angles are congruent. Rectangles, opposite sides are equal and parallel. So a rectangle is a parallelogram. Rectangle is a parallelogram because the opposite sides are parallel and equal. The opposite angles are equal as well. So equal, 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 and equal. So everything about a rectangle is parallel except that you have to add in here that all angles are right angles. This is a key. A square is also a parallelogram, except that all of these are equal. Opposite sides are parallel, all sides are equal, and all angles are 90 degrees. These two here, crucial. A rhombus. Here's a rhombus. All sides are parallel. All sides are equal. So basically a rhombus is a square that's been knocked over a little bit. The only difference is that this right here, diagonals bisect each other at right angles, is not too important. It's basically a square that's been angled over a little bit. Trapezoid, any quadrilateral that where one pair of opposite sides is parallel is a trapezoid. That's why right here, this is parallel with that, this is parallel with that. And a kite, I don't think we have to worry about. So this is some very important things to know. All right, let's classify each of these quadrilaterals of each of the rugs below. Please notice here, same. These are equal. Equal but not 90. Equal but not 90. So what we have here, opposite sides are equal, opposite angles are equal, but there is no 90 degrees, so we would just say that this is a parallelogram. Notice this next one. It doesn't look like it is, but all of this stuff right here, all of them are congruent. They're the same. The angles are all the same. So since everything is the same about this, and all 90 degrees, you say that this is a square. All right, let's classify this quadrilateral. Opposite sides are the same. They aren't all the same, but just the opposites are. And all of the angles here are 90 degrees. So opposites are the same. Everything, all the opposites are parallel. Angles are 90 degrees. This is a rectangle. All right. So this is 9.5. And your homework, or you need to do your CYUs, which are problems 1 to 4 on page 496, 1 to 4. In class, of course, we will be working on this. Good luck.